Welcome back. In session 1 of week 2, we explored variables and data types in C#, what a variable is, why we use different containers for integers, decimals, text, booleans, and more, and how naming conventions and constants keep our code clear. Today, in session 2 of week 2, we turn to operators and type conversion. We'll learn how to perform arithmetic with plus, minus, multiply, divide, and remainder, compare values, combine logical expressions, use the conditional question mark operator for concise branches, and convert safely between types. Let's dive into operators and type conversion in C#. Content overview. In this session, we will cover what operators are: arithmetic operators, comparison operators, logical operators, the conditional or ternary operator, assignment operators, operator precedence, type conversion. An operator is a symbol or keyword that performs an action on one or more values or variables, called operands. In C#, we use operators to calculate, compare, and combine data before storing or displaying the results. Arithmetic operators let you perform basic math: addition, subtraction, multiplication, division, or modulus to obtain remainders. You'll use these every time you add up totals, calculate averages, or handle loops based on numeric conditions. Comparison operators evaluate relationships between two values and return true or false. You have equal to, not equal to, less than, greater than, and their inclusive counterparts. Use them to validate user input, sort collections, or decide which branch of code should run. Logical operators combine Boolean expressions. Logical and requires both sides to be true. Logical or requires at least one side to be true. Logical not inverts a true to false or vice versa. They are essential for complex conditions, such as requiring a minimum age and a valid license before granting access. Here is the truth table illustrating how logical and or evaluate for all combinations of true and false, and how not flips a value. This helps you predict exactly how your compound conditions will behave. C# uses short-circuit logic. With AND, if the first expression is false, the second is never evaluated. With OR, if the first is true, the second is skipped. This not only improves performance, but also prevents runtime errors like division by zero in a chained condition. In this example, we check if a person is at least 18 and holds a valid license. Only if both conditions are true will the code inside the block execute, printing, "You can drive." Deep. Here we use OR to allow access if the username matches admin or the password matches password 123. Although not secure for real applications, it clearly demonstrates how a single true operand grants access. This example shows the NOT operator. If the user is not logged in, we prompt them to log in first. A simple yet powerful way to handle the absence of a condition. The conditional operator allows you to express a brief if-else statement in a single line. Result equals condition followed by value if true and then value if false. For instance, you can assign a status string to pass or fail depending on a score, all in one statement. This feature enhances code readability and efficiency, making it easier to manage conditions without lengthy blocks of code. Assignment operators bring together calculation and storage in a single action. The first one is for basic assignment. The second one adds a value and then assigns it. The third one subtracts a value and then assigns it. The fourth one multiplies a value and then assigns it. The last one divides a value and then assigns it. These tools help maintain clarity in your code while updating variables. Operator precedence determines the order in which operations occur, from highest to lowest, parentheses, arithmetic, comparison, logical not, logical and, logical OR, and finally assignment. Understanding this prevents unexpected results. Consider 5 plus 3 times 2. Multiplication happens first, so you get 5 plus 6, which equals 11, not 16. Remembering operator precedence rules saves you debugging time. In this Boolean example, comparisons run before the AND, so the value of A is greater than the value of B, and the value of B is less than the value of C. Evaluates the condition separately, then applies the conjunction to the results, yielding false. For x is greater than 10 or x is equal to 5 and x is less than 10, the AND operation binds more tightly, so it's equivalent to x is greater than 10 or the rest, x is equal to 5 and x is less than 10. Always use parentheses to make complex expressions clear. To write clear, maintainable conditions, use parentheses to document your intended order. Don't rely on memory. Refer to a cheat sheet. Break long conditions into named Boolean variables. Test edge cases thoroughly, especially with logical operators. In C# there are three main ways to convert between types: implicit conversion, done automatically by the compiler; explicit conversion, requiring a cast parsing strings to numbers using convert methods or parse functions. Implicit conversions occur when the compiler can safely widen a type, such as int to double. Explicit conversions require you to cast manually, for example, int 3.14, which may truncate data. Parsing covers converting from text to numeric types. Use convert.toInt32 string for direct conversions, int.parse, which throws on invalid input, or int.tryparse, which returns a Boolean indicating success. To convert any value to text, call toString on the object. In this snippet, we prompt the user, read a line of text, and convert it to an integer with convert.toInt32. We then perform our calculation and print the result, being mindful that non-numeric input will crash this code. To avoid runtime errors, use int tryparse. It attempts to convert the text, returns false on failure, and leaves your program running so you can display a friendly error message instead of crashing. Today we learned how to use arithmetic, comparison, logical, conditional, and assignment operators, the importance of operator precedence and how to control it, methods for converting between data types safely. Keep these principles in mind as you build more complex logic. In your Week 2 lab, you will build a simple calculator that prompts for two numbers, performs addition, subtraction, multiplication, and division, displays each result clearly. This exercise will reinforce everything we covered today. Here is a basic code template to get you started on the calculator lab. You can modify it to handle exceptions or add more operations as you see fit. And that wraps up Week 2. You've now mastered the fundamentals of storing and manipulating data in C#, from declaring variables and choosing the right type, to applying operators and converting between types without errors. In your lab this week, you'll build a simple console calculator to cement these skills. Next week, Week 3, we'll shift our focus to computer organization and conditions, exploring how code maps to hardware and how conditional logic drives program flow. Enjoy your practice, and I'll see you in Session 1 of Week 3.